All right, so I am doing chapter 11, question number 3. And for my prompt, it's going to be on tips. So the prompt says, a pizza delivery driver always trying to increase tips runs an experiment on his next 40 deliveries. He flips a coin to decide whether or not to call a customer from his mobile phone when he is 5 minutes away, hoping the slight bump in customer service will lead to a slight bump in tips. After 40 deliveries, he will compare the average tip percentage between the customers he called and those he didn't. So the question that they gave me was, what are the experimental units and how did he randomize treatments? So first, I'm going to explain my studies. So I have observational study, which is a study based on data in which no manipulation of factors has been employed. And I did a randomized experiment, which is an experiment that is using experimental units to treatment groups using some form of randomization. So designing an observational study, it says see prompt above so that I don't have to rewrite it over. But the question that I came up with was, would your design be retrospective or prospective depending on the subjects and what is being caused? And I'm choosing prospective because we already know the subjects that are the 40 deliveries that the pizza delivery driver is making, and the subjects are being followed to observe future outcomes. So we don't know exactly what the outcome will be because everything will be random. So I will say that I'm going to put down that my answer is observational studies will be a prospective study because the delivery driver has already identified his subjects to be the next 40 deliveries. So that's my observational study. Now with the randomized experiment, we're going to use our subjects for treatments. But first, I have to identify one explanatory variable called the factor, which is going to be the randomization with the deliveries. And my response variable is what I'm going to measure, which will be the randomization of the coin flip with the deliveries. So the experimental units are going to be the participants of the 40 deliveries the pizza delivery driver will be making. And he randomized the treatments by flipping a coin that would determine if he will call a customer from his phone. And with doing so, he doesn't know who will and who won't give him a tip based on calling and not calling. So as you can see with my chart, I have the number of deliveries that the delivery driver will be making, which is 40. And because he's flipping a coin, we're going to do heads and tails. But I chose to do numbers because the formula that I use for trying to pick something random wouldn't allow it to be heads or tails. So instead, I'm labeling 1 or 2. And as you can see over on the side, 1 equals yes for calling the customers, and 2 means no for calling the customers. So as you can see, we have more heads than tails, and that's from doing the numbers randomly. So I'm going to show you how I did it. So I'm going to do ran between, and I'm just going to do 1 and 2, and it's going to show like a random number. So as you can see, it says 1. So if it says 1, you're gonna just put it under heads, and if it says 2, you're just gonna put it under tails. So after I randomly put the numbers in for each delivery, I'm going to calculate how many he has for yes to calling and how many he has no for calling. So I added all the heads and I ended up getting 26 for yes for calling, and I added all the tails and I got 14 for calling. And one thing you don't want to get confused with the tails is that we're not adding twos. That the 2 is just the example because I couldn't put tails down. So you're just putting 2 for each time we put the random number in for the delivery. So it ended up being 2 14 times, so that's what I ended up getting. So after estimating the total for both flipping the coin randomly, now I will divide my totals by the total number of deliveries to get the average tip percentage between the customers. So over here, I got the average tip percentage for yes and the average tip percentage for no. And I'm going to grab my calculator. And since there are a total of 40 deliveries, the numbers that I have for heads will be what's divided to get my percentage for yes, and the numbers that I have for tails will be my percentage for what I get for no. So I'm going to go and do heads first, and as you can see, the sum down here will be 26. So I'm going to grab my calculator and do 26 divided by 40, and that's going to give me 65% for the average tip percentage for yes. And I'm going to do the average for 14. I'm going to do the average for tails, and the sum of that is 14. So I'm going to do 14 divided by 40, and that gives me 35%. So now the question remains, what are the experimental units and how did he randomize treatments? So my experimental units are the number of deliveries that the piece of delivery driver is making, which is 40 deliveries. So those will be considered my subjects. And how did he randomize the treatments was me using the rand between formula to show the randomization of the numbers. So yes, that is all.